assignment presentation over our research proposal project. As technology and science continue to move forward worldwide, it's important that our education system not only keep up with the world, but be as far ahead as possible to provide students with a firm foundation in science. Unfortunately, science education in America continues to struggle to produce scientifically literate students able to meet the world's demands. There are many ways to address problems in science education, but this presentation will focus on teachers' beliefs about learning and what they actually practice in the classroom. Teachers' beliefs about student learning impact how they teach in the classroom. A belief associates a characteristic with an object, and beliefs can range from more objective and descriptive to more subjective and evaluative. For example, teachers hold certain beliefs about what constitutes a positive learning environment, but these beliefs may or may not line up with what research says makes up an effective learning environment. These beliefs that the teacher holds will ultimately heavily influence their attitudes and behaviors that translate into teaching in the classroom. For successful student learning to occur, teachers' beliefs about learning must originate in evidence-based information. This information can include a wide variety of topics like pedagogy, sociocultural dynamics, and learning theory and educational psychology. One very well studied form of learning theory and educational psychology is constructivism. Constructivism is a perspective on learning that states that knowledge is not transmitted passively, but rather built and constructed by the learner. Activities center around forming relationships with ideas through active engagement. This leads to my research question, which is, how do science teachers' beliefs on teaching and learning relate to constructivism-type instructional activities performed in the classroom? This proposal is going to be a quantitative research project using information from the 2013 Teaching and Learning International Survey, also called TALIS. The results from the entire TALIS include responses from 14,583 teachers from countries such as Poland, Norway, Mexico, Finland, Denmark, and Belgium, but not all of this data was used. The overall population of 14,583 was sorted into a subpopulation based on TALIS question 15, which asks teachers which subjects they teach. And one of those options is science. So the data was sorted to only science teachers. After sorting in SPSS, the population now comes to 6,190 teachers who teach science, and they are from Poland, Norway, Mexico, Finland, and Denmark. Of the 6,190 teachers who teach science, 78% were female. The average age was 43 years old, and the average total time teaching was 16 years in length. TALIS question 32 was the only question that directly dealt with teachers' beliefs on teaching and learning. And thus, most of the data collection is going to revolve around question 32, A through D. The main question is, We would like to ask you about your personal beliefs on teaching and learning. Please indicate how strongly you agree or disagree with each of the following statements. As answer options, participants could select strongly disagree, disagree, agree, or strongly agree. The 4 sub-questions A through D include: my role as a teacher is to facilitate students' own inquiry. Students learn best by finding solutions to problems on their own. Students should be allowed to think of solutions to practical problems themselves before the teacher shows them how they are solved. And thinking and reasoning processes are more important than specific curriculum content. Because I'm interested in constructivism in the classroom, I searched Tallis to try to find questions that included classroom activities that had a constructivist approach. And although the case could be made for several different questions, the 2 that I thought were most obvious were Tallis question 33C and 42B. 33C says, on average, how often do you do the following in this school? And then specific to C is engage in joint activities across different classes and age groups, e.g. projects. And for the answer options, teachers could select never, once a year or less, 2 to 4 times a year, 5 to 10 times a year, 1 to 3 times a month, or once a week or more. Question 42 asks, how often does each of the following happen in this class throughout the school year? B specifically asks about students working in small groups to come up with a joint solution to a problem or task. The teacher answer options here are never or almost never, occasionally, frequently, or in all or nearly all lessons. Statistical analysis was performed in SPSS. Descriptive statistics were analyzed, and any potential relationships between the continuous variables were uncovered using Pearson correlation. This is the first of 4 data slides that show the results from the Pearson correlation test I ran in SPSS. The first one compares the questions of my role as a teacher is to facilitate students' inquiry, which is from Tallis, question number 32. And this was compared to the Tallis question 33, engaging in joint activities across different classes and age groups. And then also to Tallis 42, which is on students coming up with joint solutions together. And across the board, there was significance in these relationships. However, the Pearson correlation coefficient was rather low, so these are not really strong relationships. If teachers held the belief that students learn best by finding solutions to problems on their own, this was statistically correlated with the classroom practice of students working in small groups to come up with a joint solution, and engaging students in different classes and age groups for projects, although again, it was not a strong correlation based on the Pearson correlation coefficient. For Tallis 32C, students should be allowed to think of solutions to practical problems themselves before the teacher shows them how they are solved. This was significantly correlated with the other two TELUS questions on engaging in activities across different classes and age groups, as well as coming up with solutions together as a small group. Although, again, the Pearson correlation coefficient was very small. And last is TALUS 32 Part D, that thinking and reasoning processes are more important than specific curriculum content. When I ran the correlation with this against the other